All right, let's talk about the invisible force that runs basically everything in our digital lives, computer software. It's often called the ghost in the machine, and for good reason. It's the magic set of instructions that brings all that physical hardware you can touch to life. So let's dive right in. I mean, really think about it. What you see on your screen, that's just the tip of the iceberg. Every single time you click an icon or, type a message or fire up a game, you're only interacting with the very, very top layer. Underneath all of that, there's this huge hidden world of code and processes, just humming along, making it all happen.
So, what is software, really? Well, at its most basic, it's just a set of instructions, a collection of computer programs that run on the hardware. It's the essential bridge that connects you to the physical machine, the thing that allows the hardware to actually, well, do anything useful.
Okay, now here's where it gets really interesting. To get a handle on software, you gotta know that it's not just one big blob of code. Nope, it's actually divided into two fundamental categories. You could almost call them two secret worlds, and they have to work together perfectly. And this is where that iceberg analogy really pays off. See, on one side, you've got system software. That's the huge part of the iceberg hidden under the water. It's the engine room, the stuff that manages the computer itself. Then, on the other side, you have application software. That's the tip of the iceberg, the part you actually see and interact with every day. And here's the key takeaway. Your apps, all that stuff you use, they are completely useless without the system software foundation holding everything up from below. So, let's dive under the water and explore that hidden engine room first. We're talking about systems software. This stuff is the absolute foundation. It's all the programs running in the background, making sure your computer is, actually computing. Think of system software as a complete toolkit for your machine. The biggest, most important tool is the operating system. That's the manager of the whole operation. But you've also got things like language processors, they're the official translators, and then there's a whole crew of specialists. Utility programs are the maintenance crew, loaders get programs ready to run, and editors help shape the code in the first place. All of them are working away in the background, totally out of sight. Okay, so out of all those tools in the kit, one of them is the undisputed boss, the big kahuna. And that is the operating system, or as we all know it, the OS. I love how our source material puts it. The OS is the fundamental software that manages a computer's hardware and software resources. It's basically the master controller, right? The essential go-between that lets you and your apps talk to the physical hardware. It sets the stage so that everything from your web browser to your favorite game has a stable platform to run on. So what does this boss actually do all day? Well, it's got three main jobs. First, it manages all the resources. It's like a master juggler, keeping the CPU, the memory, and the storage all in the air and making sure every program gets what it needs. Second, it handles all your hardware, your keyboard, your mouse, your monitor, you name it. And third, it's the one that actually runs your programs, giving them the foundation and control they need to do their thing. And, not all bosses are created equal. You've got your single-user OS, which is probably what you're using right now on your laptop or phone. It's designed for, well, one person at a time. But then you have multi-user operating systems, and these are a whole different beast. They let tons of people on different computers all access the same system at once. Think about a bank's main server or a big university network. That's where you'll find these powerhouses. All right, so we've spent some time down in the engine room. Let's head back up to the surface and take a look at the part of the iceberg we all know and see every day: application software. This is the big difference, right? System software works for the computer, but application software, it works for you. Its entire reason for being is to help you get something done, whether that's writing a report, calculating a budget, or just connecting with friends. And yeah, this is the software you use every single day, probably without even thinking about it. We're talking about word processors like MS Word, spreadsheets like Excel, database management tools like Oracle or MySQL, and of course, presentation software like PowerPoint. All of these are designed to make our lives easier and more productive. So where does all this application software come from? Well, if you need an app, you've basically got two choices. You can go with off-the-shelf software. You just buy it, it's cheaper, it's been well tested, and it's ready to go immediately. The downside? It might not do exactly what you want. The other option is to build in-house or bespoke software. This stuff is custom-made just for you, so it's a perfect fit. But it's going to cost you a lot more, and it takes a long time to develop. Which kind of brings up a really cool question, doesn't it? How is software even made? I mean, how do you take an idea from a human brain and turn it into a set of instructions that a box of circuits can actually understand?
Well, the magic happens thanks to a special piece of system software called a language processor. See, humans write code in programming languages that are kind of readable, a bit like English, but computers, they only speak one language, machine code, just zeros and ones. The language processor is the indispensable translator that sits in the middle, converting our human-friendly code into the binary that the machine can execute.
Now, there are two main ways to do this translation. First, you have a compiler. Think of it like translating a whole book at once. It reads the entire program, translates it into machine code, and spits out a separate file that can run really, really fast. Then, you have an interpreter. This is more like a simultaneous translator at the UN. It translates and runs the program one single line at a time. It's a bit slower to run, sure, but it makes it way easier for programmers to find mistakes as they go. And wow, have these programming languages evolved. We started way back with the first generation, literally just punching in zeros and ones. The second generation gave us assembly language with little shortcuts like add. A bit better. Then came the third generation with languages like Fortran and BASIC, which started to look more like human language. Fourth-gen languages made complex jobs like database queries much simpler. And that brings us to today, with fifth-generation languages like Python and Java that let us build the incredibly complex apps we rely on every single day.
So when you really step back and look at it, it's clear. Software is the invisible architect of our entire digital world. From that hidden OS managing your hardware deep inside your computer to the app on your phone you just used to order coffee, it's all built on layers and layers of code. Each generation has unlocked things that were once unimaginable. Which really makes you wonder, doesn't it? What incredible things will the next generation of code allow us to build?